All right, so here we have this complex fraction. Most students prefer to use the first method, which is to rewrite the numerator as a single fraction, do the same with the denominator, then invert and multiply them. And so if we were to combine the numerator into one single fraction, the LCD would need a factor of x plus 2 and x plus 1. So we would take our first fraction's numerator times the LCD factor missing from its denominator. It has the x plus 2, it's missing the x plus 1. Plus the next fraction's numerator, x minus 1, times the LCD factor missing from its denominator. It has the x plus 1, it's missing the x plus 2. So if we work through and simplify this, so we're going to FOIL. We get x squared plus x minus 2x nets you negative x, and then minus 2. Plus FOIL our next set of next binomial. X squared plus x and minus x nets you a plus x, and then minus 2. So here the x's cancel, and you're left with your numerator of 2x squared minus 4. That's all over x plus 2, x plus 1. So here's our numerator written as a single fraction. Okay, we're going to do the same thing with the denominator. We're going to combine these two into one single fraction. Here the LCD has to have a factor of x plus 1 and a factor of x. So here's your LCD. Take the numerator of the first fraction times the LCD factor missing from its denominator. It's missing the x. Minus the next fraction's numerator, the binomial, times the LCD factor missing from its denominator, which is x plus 1. Okay, so here I'm going to go ahead and simplify this out. So I have my x squared. I am going to FOIL this. I get 2x squared plus 2x minus 3x nets you minus x, and a minus 3. I'm then going to distribute my negative here. And finally, when I combine my like terms, I get negative x squared plus x plus 3. So the first thing I'm going to look to see is, can I remove any common factors? Here I could remove the negative. Okay, so if I take out the negative, I'm left with x squared minus x minus, and that's all over x times x plus 1. Okay, so this is the denominator of my original fraction. Okay, once I get to this point, what I'm going to do is, instead of, I've now got this single fraction divided by another single fraction, so I'm just going to invert and multiply. So this negative x squared minus x minus 3 gets moved to the denominator, and this x times x plus 1 gets moved to the numerator. Okay, so that's just taking all of this and moving it up. And then my final step is to cancel any common factors if there are any. And so when I look to remove any common factors here, from the numerator I can factor out a 2, leaving an x squared minus 2. So when I multiply these out, the x plus 1s cancel, nothing else does. Never put a negative in the denominator of a fraction, so I'm going to move this negative up. And so I get a numerator of negative 2 times this x squared minus 2. So there's my numerator. And then in my denominator I have this binomial factor x plus 2, trinomial factor x squared minus x minus 3. Okay, once I have my simplified form, I need to go back in and identify any domain restrictions. Because I inverted and multiplied, I have to consider not just those in the denominator, but also the factors of this second fraction's numerator, because they originally were in the denominator. So I have to account for x can't be negative 1. That's not shown. X can't be, again here there's no rational zeros for that. Up here though I do see that x can't be a 0. Since that's not shown in the simplified form either, I do have to restrict that as well. So I have domain restrictions that x can't be negative 1. It also can't be a 0. So those would be your restrictions for that one.